Hi guys, I'm Smita and welcome back to my channel where I talk about all things AI and machine learning related. In today's video, we're going to be creating an end-to-end machine learning project which is looking at IMDb reviews and deciding if it's going to be positive or negative. So based on our ML model, that's what we're going to be doing today. And the twist to this rather basic project that anyone can follow along with is that we are going to be making use of a machine learning platform called Comet, which is able to analyze and give us a lot of data on the machine learning model that we have built. By the end of this, you should have a dashboard which looks something like this, and that is going to be extremely useful for you guys. So let's get started. So in this project, what we're going to be doing is looking at these IMDb reviews, and we're going to be training our machine learning model on labeled IMDb reviews. And based on that, our machine learning model is then going to be passed unlabeled reviews. So you don't know if it's positive or negative. And based on this, our machine learning model is actually going to deduce whether a review it has been passed is either positive or negative. Now, let's look at the type of data set and the model that we're going to be using. So we are going to be making use of this particular data set called IMDb. Now, since this problem is a natural language processing problem, we are going to be making use of the distilled BERT machine learning model, which is a distilled version of the BERT NLP machine learning model. I'm going to be leaving a link for both of these in the description box below so you guys can read up more if you're interested. And now coming to the most interesting part about this machine learning tutorial is that we're going to be making use of this machine learning platform called Comet. So Comet is a machine learning platform which is integrating our existing ML infrastructure and tools in order to visualize and optimize our ML models. And it's extremely interesting because there is not a tool like this out there in the market where you're able to get all of the stats of your ML model in one single platform. So that's very interesting. And in order to complete this tutorial, we need to have a Comet API key. So go ahead and click the link in the description box below, create an account, and you'll get a free API key so that we can make use of this platform for this tutorial. Once you have created a Comet account and you've gotten your API key, let's head over to a Google Colab file and start the project. So once you have opened your Google Colab, the first step that we're going to be doing is installing Comet and also a lot of other dependencies as well. So go ahead and do pip install Comet ML as well as PyTorch, dataset transformers, and scikit-learn. And go ahead and run this. Once all the libraries have been downloaded, and that should take some time, we're going to go ahead and initialize the Comet library that we have just downloaded. So go ahead and type import Comet ML as well as Comet ML .init, and then we're going to actually give the name of the project that we want to create on the Comet platform itself. So we are going to name this project name equals IMDb distill BERT. And then let's go ahead and run this cell. When you run this cell, you're going to get a prompt which is asking for your Comet API key, which you can easily find in your Comet settings. So go ahead into settings and look under developer information. Under developer information, click on API key, and upon clicking on this, you're going to copy the API key. And once that has been copied, just go ahead back into the Google Colab file and just paste it. Once you have initialized Comet, this means that whatever input we're giving in this Google Colab file, that is going to be sent over to the Comet platform, and we're going to be able to see all of that data on the Comet platform itself. So that's great. And once that's done, let's actually initialize some constants that we'll be using throughout this project. First thing is the name of the model, which we are using from Hugging Face. So I'm going to name that pre-trained model name. We can copy the name of the model right from the Hugging Face website. So distill, BART, base uncased. And also we want to set a seed, and I'm going to be setting a seed of 20. Now that we have set up the name of the model that we're using, let's actually get the data set as well. Now that we have done that, we're actually going to be loading the data. And in order to do that, we are going to be importing two really important libraries from Hugging Face. That is the Transformers library as well as the datasets library. Our datasets raw dataset equals to, and we're going to call the load dataset function. And the dataset that we're importing from Hugging Face is the imdb dataset. So that's what we're going to call. And let's run this cell. Next up, we are going to be setting up and initializing a tokenizer. A tokenizer helps to format our input data so that it's better understandable by the NLP model. So let's go ahead and do that. Once we have defined this function, tokenize function, we are going to be creating a brand new tokenized dataset where we pass in our raw datasets in order to get a tokenized version of those datasets. We're also going to initialize and set up a data collator. A data collator actually helps to split our data into batches, and that will be useful later on. Once that's done, let's actually create our new sample datasets from the tokenized version of the datasets and actually split that into a training dataset and an evaluation dataset. That's good to go. And now we're going to set up our transformer model. Once that step is done, now we're going to actually set up a very simple evaluation function. And the most important thing about this evaluation function is that we're actually going to be sending all of the metrics onto Comet's platform, and we're going to have a method specifically for that. So let's take a look at exactly how we'll go about doing that. So from sklearn metrics, we will be importing accuracy score. So this really simple get example function, all it does is it returns the exact piece of text that we're actually passing into the model in order to get an evaluation out of that. So this is going to come useful later on when, for example, we want to pass our text onto Comet's platform and you want to view text on the platform. So let's look into that. Next, we're going to be creating a method called compute metrics. And the main thing here is that we are creating an experiment. We're actually initializing an experiment, and experiments are a core part of making use of Comet's platform because it really helps to log experiments as well as log all the metrics of our current experiment onto Comet's platform. So experiment equals to Comet ML dot get global experiment. Now that we have defined our training and evaluation datasets, our model, and also what is our evaluation function, let's actually go ahead and start running. In order to do this, we need to first create two environment variables, which will actually help us to log our experiment values and also all the metrics onto Comet's platform. So let's do that. And then we will go ahead and define our training arguments. Once we have written this entire cell to train our model and run the training, so let's actually go ahead and run this cell. So the cool thing with this is that you automatically get, that experiment is live on comet.com, and it gives you a link automatically, so you can click on this to view the experiment. When I actually click on the link, this is the experiment right here. As you can see, there's so much data that we actually get. We can view charts from our training run. We can see the loss on each step, as well as the total F loss and the number of epochs, the evaluation accuracy, evaluation loss, and many, many more. Now, if I go into panels, I can also add other types of graphs or other types of visualizations that I'm interested in adding. And also, if we go onto the code panel, we can see all our code that we have put onto Google Colab right on this platform itself. And from here, you can actually view it or download it again. And one of the most interesting thing is if you go on to the hyperparameters, we can view all the hyperparameters used in our model, the data loader, as well as the framework. So this is super interesting to keep a track of the type of model which is used in a particular run. So that's very interesting as well. And if we go into metrics, we can see all the metrics right here as well. For example, loss, training loss, and runtime as well. Under graph definition, we get a very interesting outlook of the machine learning model that we used. We actually get a layer by layer breakdown, so you can completely understand exactly what type of layers are inside of the distill-BERT model that we made use of. And this is extremely useful in situations where we have made use of a pre-trained model. So we haven't defined all of these layers in our Google Colab, but it's really important to look at these layers if we want to make any changes after the fact, after training, or if we find that, hey, if I switch this layer out with something else, the model could perform better. It's interesting and very important to have this layout to look at. And if we look under the tab of system metrics, we get to see all the metrics of our GPU usage, our memory usage, as well as CPU usage. We also get to see our Python version, as well as OS type and what type of machine and processor we were dealing with. So that's also really great to have on hand. And if we go on to installed packages, and I personally find this pretty neat, because oftentimes with Python libraries, you might face a lot of issues with versioning, right? And if you want to replicate a particular project, or if you want to replicate a particular ML model exactly how a certain developer or exactly how you might have done it, it's important to have maybe the exact versioning of the Python libraries that you made use of. So it's cool that they have a function which actually does that. Another extremely useful thing I find is that depending on the data type that we're dealing with, in this situation where we're dealing with text, we can actually log the text. So if we go under text, you can see that I've actually logged the data and the training data as well as evaluation. We can actually find the evaluation data here that we have used and all of the examples as well. So this is something that is personally very useful, especially for visualization. If you want to look at data, you don't have to go into a CSV file separately. It's great to have them all on hand right here, and you can see the label of the data as well, whether it was classified as negative or positive, and also the exact step that this data was actually evaluated in. And then we have the confusion matrices tab, which is very, very neat. We can essentially look at exactly what the model got right and what it got wrong. So what type of data it actually predicted correctly, accurately, and which ones it did not. So for example, in this situation, we have 4 different reviews which were actually positive, but the model actually misclassified them as negative reviews. And if you can actually go ahead and look at exactly which type of reviews there were, and you can see exactly all the data right here. So you get to kind of understand maybe why exactly the model made mistakes as well. So these are really helpful to have on hand. And in the event that we're dealing with images, you can also log images to Comet as well as audio data as well. If I go up here into imdb distill BART, which is the folder I created, I can see all the other experiments that I've ran with this particular data set, which I've stored right in this folder. And you can also see the combined results of all the experiments as well. So you can see which experiment did really well in terms of having the lowest loss and which experiments didn't do as great. And you can see how they compare in terms of evaluation runtime, evaluation loss, as well as training loss. So I think this is an extremely useful tool, not just for ML engineers who are working on highly advanced models, but this is a great tool for beginners who are starting out as well, and they want a lot more access to metrics as well as a lot better visualization and having everything at one aspect and not having to look at a bunch of different things or trying to use multiple different programs in order to identify different metrics in your ML model. And the fact that this platform displays a lot of the entire pipeline, essentially of your ML pipeline, it has a lot of different metrics from every aspect. I think this is very useful for both beginners as well as experienced ML engineers as well. So guys, let me know what you thought about this tutorial in the comment section below. The link to Comet's platform will be in the description box below, so do check that out. Hope you guys enjoyed this tutorial, and thank you guys for watching. See you in my next video.